Welcome back, everyone. Today is a beautiful day. It's sunshine outside, and we have a little snow in my town. Anyway, it has been a while. My computer was crashed. So today I'm so happy to get everything set up again. It takes time for me to check the resolution for my screen. It's a process of learning. But anyway, I'm glad that my computer has been set now. The only thing I regret is my money was gone to have it fixed because I cannot fix it by myself, right? But anyway, today we will have the new topic in our new lesson, which is sketching rational function involving the optical asymptote. In the past, I have shown you how to sketch the horizontal asymptote based on the analysis of vertical asymptotes, horizontal asymptote. But today we'll learn one more step, which is optical asymptotes. So what is optical asymptote? And the spell of it is here. Sketch rational function with the optical asymptote. So what is the optical asymptote? Now we're not going to know it until we sketch it. However, I would like to give you a hint. The optical asymptote happens when the degree of the numerator, the highest degree of the numerator is higher than the highest degree of the denominator. For example, here you have x squared on the top, but you have x to the power 1 at the bottom. So we notice that x squared bigger than x to the power 1 for sure. So whenever it's like that, then we have the optical asymptote. But how do we find the optical asymptote? We know that, yes, in our rational functions, we have an optical asymptote by its degree. But how do we find it? The only way we can find it is divide the numerator by the denominator. Like any fraction you learn, we can divide the numerator by the denominator. And the way we divide variables in high school is the same like we divide in elementary. So let's take a look at it. So I'm going to divide x squared, and I'm going to put here like actually, okay, let's divide like this. X plus 1. Now, because we don't have an x here, but I pretend that we have an x, right? So I put a 0 here for 0x. And we don't have a constant as well, but I'm going to put a 0 for the constant. It's just too easy to make a reference. So now, just like the way we divide, this is our divisor, and this is dividend. Actually, it is the other way around. I forget. It's divisor, dividend. But the answer on the top, when we find it, we call a quotient. So whatever answer on top, we call a quotient. And let's see if we have a remainder as well, right? So to divide this polynomial, I will find a number and I put on the top, right at this column, right? Because that's the x. This number x multiplied with the x here will give me an x squared. And that's why I put it there. So x times x is x squared. X times 1 is 1x. Plus 1x. Now I'm going to subtract just like the same way you divide a fraction in elementary. This subtract this will be 0. This column subtract this column. Notice this is negative. So we have 0x subtract 1x. So it becomes minus 1x. Continue, we bring the 0 down. We're going to find the number. Time with this 1, we can subtract. So that should be minus 1. 1 times minus 1 times x is minus x. Minus 1 times 1 is minus 1. Now I'm going to subtract between them. Notice this subtract multiply with this negative, it becomes a positive. So a positive of x adding with the negative of x, you see, become a result, right? Because negative times negative positive. So positive 1x minus 1, subtract 1x, so it becomes 0. Minus 1 times minus 1 is positive 1. So we have positive 1 here. So this equation actually turned out to be, so we have f of x equal x squared over x plus 1. We can write this as the answer. This is the quotient, right? This is the quotient. And this is the remainder. So we can write it as the quotient and the remainder, which is x minus 1, adding with 1 here left over, but this 1 will continue to divide by x plus 1. So this is basically, this is the answer. And we know this left side equals this right side. So now when we look at it, what do we realize? We realize that this linear here is the oblique asymptote. And that's the reason we divide. We divide so that we know what is the equation of our oblique asymptote. So the linear x minus 1 here is the oblique asymptote. So I just put in the short form, right? Okay, so now we're going to find what else do we need to find. To sketch the function, we find optical asymptote if we find the degree on the top higher than degree at the bottom. Now we're going to find vertical asymptote. So what is vertical asymptote? The vertical asymptotes happen when the denominator becomes 0. At that time, the function does not exist. And that's why where the function does not exist, we have a vertical asymptote. And the vertical asymptote here is x equal minus 1. Because if we put minus 1 in here, minus 1 at 1, of course, is 0. So now let's get the vertical asymptote. Vertical asymptote x equal minus 1. So minus 1 is here. So we have our vertical asymptote here. And I put it by dotted line, stand for the asymptote. So what next? What about the horizontal asymptote? Now, remember, we find the horizontal asymptote when we look at the x value getting into a very large number, negative and positive infinity, right? So if you look at here, the highest degree on the top will let us know that we don't have a horizontal asymptote because the x squared approach to big infinity, you divide by a small number, right? Whatever it is, 0 point, whatever it is, or maybe 5, 6, or whatever, right? This will, if you have a bigger number on the top and a very small number at the bottom, what does it tell you? It tells you that this number is still big, still huge, right? And it's too big that we cannot find it. So therefore, we don't have a horizontal asymptote. So we say no horizontal asymptotes because the degree on the top higher than the degree at the bottom. Okay, so what else do we recognize? So now we're going to sketch the optical asymptote. So the optical asymptote is a straight line linear at -1 is the y-intercept. And the slope is 1 over 1. The rise is 1, the run is 1, right? The slope equals rise over run. So we go rise 1 unit, go run 1 unit. Go rise 1 unit, go run 1 unit. And if we go the other side, we go down 1 unit and okay. So basically, this is the optical asymptote. Go to this point. Okay, so now we know our optical asymptote right here. So we have vertical asymptote, optical asymptote. Now, how do we sketch this function? We sketch this function based on a few points, right? First of all, let's take a look at the, where do we put the pen? Do we put up here? Do we put down here or here or here or here? We don't know. So let's take a look at the y function behavior when the x approaches to this vertical asymptote, both sides, right? When x approaches to this left side of the vertical asymptote and the right-hand side of the vertical asymptote, right? So let's take a look at, so when x approach to -1 on the left, right? -1 on the left. What is y approach to? Y approach to what? That's our question. So let's figure out. So if you put this function here, x squared over x plus 1, and if your x approach to -1 on top, you square it, it will become +1. Down here, -1 on the left, it means you will divide this by minus on the left. So it's -1.001 adding with 1. So this is the same as 1 divided by minus 0.001. So when you have a small number on top divided by a very small number at the bottom, it turned out to be a big number, right? Because this is like 1 over 1,000. And the same, like you divide, I mean you multiply upside down, so 1 times with 1,000. And 1,000 is just represent a very big number. So I'm gonna put here minus infinity. So now we know if x approach to this vertical on the left, we put our pen down here, right? And maybe I should draw this a little bit so we have more room. So we know that when x approach to this, to the left, we put our pen right here, negative infinity, right? Negative infinity. What else do we take a look? We take a look at when x approach to this vertical asymptote on the right-hand side, right? So when x approach to -1, but the positive right corner represent on the right-hand side, right? So obviously, if this is the right-hand side, you have a situation of 1 divided by minus 1 point, will be minus 0.999, right? Because we're talking about a little bit over this side, right? It will be minus 0.999 instead of -1, right? Plus 1. So this will obviously give us minus sorry, yes, plus, right? Because this number 1 winning this number. So when you subtract, this gives us the positive number. So we know it will become positive infinity. So on this side, our function is supposed to go up here, where it's positive infinity. So we know the pen, we can put the pen here to draw the function, to sketch the function, right? So what else should we look at it? We should look at the Y-intercept and the X-intercept, right? So let's take a look at the Y-intercept and the X-intercept. But before we do that, let me find some place, some room. So what is our Y-intercept and what is our X-intercept? Our Y-intercept will equal, if we put the zero for X, right? When we find the Y-intercept, we set the X equals 0. And down here, doesn't matter what number down here. As long as the numerator equals 0, then this rational function equals 0. It means we have a Y and the X-intercept as well. X is 0, Y is 0. So that is our Y-intercept. Also, X-intercept, both of them, right? X-intercept 0 and Y-intercept 0. So now we don't have to find the X-intercept because we know it. What else do we have another X-intercept? Let's see. If you set this equation 0, it's the same thing like this situation. So you're not going to find the X-intercept, right? You're not going to find another X-intercept, I mean. So it means that we have X-intercept and Y-intercept right here for this function. So we can plot the point right here, right? This is 0 for both of them, Y and X. So we know the function will go through here. Now, the optical asymptote is very amazing in the way that we can guess the function, how it go, right? So just based on this, a few points here, I know that I can sketch along with the function, along with the asymptote, right? The vertical asymptote from here and go through this point, right? And it's going to shape along with the optical asymptote, but it's never touched the optical asymptote. So that is the first branch when we sketch this function based on these features, right? What else do we know? We also know that we can put the pen here for on the left-hand side of this vertical equation. So therefore, based on the optical asymptote, I know that my function will shape along with this optical asymptote, and something look like this, right? However, if we want to be accurate, we can just say, we don't know how high this function turn the curve here, right? So it could be high like that, or it could be low like this. We don't know. So we're going to find the point right here. We're going to find this point or this point to make sure that we across the right point, so we have more accurate pictures, right? So we don't know, is that high like this or is that low like this, right? So the only way we know is substitute one point, right? Substitute the X value. And what X value we can find? Maybe -3 or -2. I'm going to pick -2, right? So put in this function, if X equal -2, find out what Y equal. And the Y will be equal -2 square, right? Based on this function, divided by -2 plus 1. And that will give us +4, divide -2 plus 1 is -1. So the Y will go equal -4, right? And therefore, we have a point X equal -2, Y equal -4. So if x is minus 2, y equal minus 4. You see minus 1, minus 2, minus 3, minus 4 about here. So our point is right here. Not here and not here. So either picture look right. So now I can re-sketch it, reshape it, right? So now I know my point is here. This is the point where x is minus 2 and y is minus 4, right? This point. So now I'm going to sketch this function, go through this point, and slightly shape along with the optical asymptote and the vertical asymptote. And that's how it is. And if you put in the graphing calculator, you will see exactly the shape look like this. So that's how we sketch the first rational function. So now let's check. In this video, I'm going to show you to sketch two of them, right? So we are already done with the first one and how is the picture look like. Now I'm going to show you one more sketching for the number 2 here. So before I do that, let me erase all of this, right? And again, if you register to my courses online, right? I put it here over x to the power 1. So we know we have an optical asymptote. And we also have the vertical asymptote, right? By x minus 1 here. So let's talking about the vertical asymptote. So we have vertical asymptote equal x equal 1, positive 1. Because if you put positive 1 in here, then this will disappear. So our vertical asymptote will be x equal 1. What is our horizontal asymptote? Now we know that the degree on the top, right, bigger than the degree at the bottom. So we have a situation that y will approach to infinity number, right? Big infinite number. So therefore, we have no horizontal asymptote. So let's find out optical asymptote, right? And we know that we will have for sure because we can divide this. So let's divide this and see what happens. X squared minus 2x plus 5. We'll divide this. So the answer, one more thing I would like to do in this question. Now, if you have learned the polynomial division, you can use a long division or you can use synthetic division. So in the first question, I show you how to divide using the long division, which is this is a review for you in the polynomial function, right? And now in the second question, I would like to use another strategy. And all of this you have learned already in my courses. So in my courses, you will learn how to do the long division polynomial first and synthetic division first before we do the rational function. So the second unit in my courses is polynomial function. And this unit is rational function. So I design the course in the logical order, right? Which one we should learn first and which one we should learn later. So if you register in my course, you already know how to divide using the polynomial function, using the long division, which is the one I just showed you in the first question. Now I'm going to use a synthetic. It's just like a review for you, right? So synthetic. Now for divide by synthetic, we just take the coefficient and ignore the x, right? So we have 1 minus 2 and 5. So now we're going to divide by the factor here is x equal 1, right? So we divide by 1. So that's how we use the synthetic, right? So I'm going to bring this down 1. Now 1 times 1 is just positive 1. Minus 2, and we add this, right? For synthetic, we add them instead of subtract them. So minus 2 add 1 is minus 1. Now we say minus 1 times 1 is minus 1. So we add them, this will become plus 4. So, yes. So now we know that this is our function. If you divide it, you will have your power going down from power 2 to power 1, right? So it would be x, and this number represents for minus 1. So our x minus 1, and then plus 4. Now this 4 will continue to divide by this as well, right? So this is our optical asymptote, right? You see, optical. So by using the synthetic here, you divide it, then you know. Now, if you just randomly watching the video on YouTube, you will say, wait a minute, I don't know what she's doing. But if you register in my course, you already learned unit 2, which is you already know how to divide the algebra expression or the quadratic, actually the polynomial function, right? Using long division, like in the first example I show you, and in the second example, synthetic, I show you now. And therefore, I went through it quickly because you already learned this in my courses. Okay, so now we know the optical asymptote is here. So now I'm going to sketch the all of this, right? So we have vertical asymptote is x equal 1. So let's sketch it. And let me put this further apart a little bit. I'm going to make a big scale for x here. So we have a vertical asymptote at x equal 1. So that's our vertical asymptote. We also have an optical asymptote at x minus 1. So minus 1 right here, and this is the positive slope as well. So we go up 1, we go across 1. Go up 1, go across 1. So this is our optical asymptote. Oh, sorry. Point, go up 1, go across 1. Go up 1, go across 1. Go up 1, go across 1. So this is our optical asymptote. Okay, so now what do we look at it? We'll look at it. So our optical asymptote is the equation x minus 1. Now we're going to look at the y behavior when x approaches to 1, but on the left side, right? So when x approaches to 1 on the left side, what happened to if x approach to 1, but on the left, then y will approach to what? We're going to substitute in here and figure it out, right? So if you put 1 to the left, it means this number is not reached 1 yet. So it's like 0.999, right? And you square it, and you minus 2 times 0.999, and you add 5. You divide it by 0.999 minus 1. So obviously, by inspection, we can recognize the number on the top, right? So the number on the top will be positive or negative. Now down here, we know this will be a negative, right? Because this number not winning this number, right? The minus 1 is bigger than this. So we have a negative sign at the bottom, and our answer very small, right? 0.01, something like that. Now on the top, we have to figure out what is our number. Is that positive or negative? Now by inspection, you will know this is going to be small number, and this is going to be a very small number. So if you have a small number minus a small number and add the big number, so number on top will be positive, right? So therefore, you don't have to calculate in, you should know this will be approach to negative infinity, right? So we're going to put down the pen down here, negative infinity. So our pen will be right here, negative infinity. Now let's take a look at if x approach to 1, but on the right-hand side. So if x approach to 1 on the right-hand side, the scenario is still a number big on top, right? Because this number 5 is big, right? And this will be, instead of 0.99, if we change it into 1.01 minus 1, right? So the situation will be positive on the top, and down here, 1.01 minus 1 is just a very small number, but it's positive, right? So of course, it will be positive infinity. So if I approach to here, our pen will be up here. Positive infinity, right there. So now, what else do we need to know? We need to know whether our function cross the x-axis or the y-axis. So we call it x and y-intercept. So let's figure out the x-intercept. So find out x-intercept by set y equals 0. X-intercept by set y equals 0. So when we set y equals 0, what do we have? We have a situation, I'm going to have to erase this ball here so that I can have room to make it look better. So if you want to find the x-intercept, you set y equals 0. So let's say this function x squared minus 2x plus 5 will be equal to 0. Now the bottom doesn't matter, right? Because as long as you have a numerator equal to 0, then you have a value. Because if you set this sign equal to 0, you pick this bracket up here, anything times with 0 going to 0 anyway, right? So we don't care about the denominator. What you care is the numerator, right? So when you set y equals 0, it means you set the numerator equals 0. Let's solve for x-intercept in here. Now by inspection, I'm going to tell you that this function has an imaginary root, which is we don't have an x-intercept. And how do I know that? In Math 10, you already learned if the quadratic function touch the x-axis at 2 points, we have an x1 root and x2 root, right? But if it's up here, we have an imaginary root because we have no root actually, right? Because our quadratic never touched the x-intercept, as long as this situation as well, right? So anything like this is not going to have the root for the quadratic function. So therefore, and how do we recognize that? We recognize that this is unfactorable. You cannot factor this expression. Second, you can use the formula b squared minus 4 times a times c. If this one is less than 0, then of course you have an imaginary root. So let's say b squared here is minus 2 squared minus 4 times our a here is 1 times our c here is 5, so like this. So you have situation 4 minus 20, which is equal minus 16, and of course minus 16 less than 0, so we have no intercept, no root. We have an imaginary root in this equation. So we know now we don't have an X-intercept. What about the Y-intercept? Now the Y-intercept happens when we set x equals 0, right? So if you set x equals 0, what this Y-intercept will be? This term will become 0. Minus 2 times 0 is 0. So we ended up with 5 over 0 minus 1 is minus 1. So equal minus 5. So now we know our Y-intercept will be minus 5. See, minus 1, minus 2, minus 3, minus 4, minus 5 is here. So this is our Y-intercept. Okay. So by inspection, we already can sketch this function, except we want more to be more accurate. So let's find a point here so that we know that our curve, actually we don't have to because we already have this point here. So let's get this. Our function will slightly follow the vertical asymptote and go to this point, and we'll go here so that it close to the oblique asymptote, but it never touch it. So this is scenario, right? Now on the top, you know that you can sketch this like this. And if you want to figure out where do we across this one, maybe that's a better idea, right? So let's set x equal, this is 1 and 2. So if x equal 2, what is y equal? Substitute in the function, we have 2 squared minus 2 times 2 plus 5 divided by 2 minus 1. So this will give us 4 minus 4 plus 5 over 1. So we get 5. So the point here is x is 2, y will be 5. So if x is 2, y will be 5. This is 1, 2, 3, 4, 5 up here. Wow. So actually, our shape will something appear go through this point, right? Okay, if x is 2, 2, 3, 4, 5. So actually here. So our shape will go look like this. And follow the asymptote here. Put it up to the top like this. So it's gonna go all the way from here, go to this point, and sketch along like this, right? So that's how the function looks like. Okay, so now let me put in the roughing calculator and check with you, right? I didn't check the first one for you, but let's check this one. So I'm gonna, okay, let's put second memory 7 reset 1 to reset. So I make sure the RAM is clear on my calculator. I'm going to key in the function. On the top will be x squared minus 2x plus 5 divided by bottom will be x minus 1. So that's how I key on the graphing calculator, right? And now let's sketch it. Oh, sorry, my calculator, the battery ran out, but you just see it. It looks the same, right? I'm sorry for this. I should have changed my battery. So anyway, that is our lesson for the graphing sketching rational function today. I hope you enjoy it, and bye for now. We'll see you in the next lesson. The next lesson, I will talk about the how to write the rational equation using the given data feature like this. Let's say they give you a vertical asymptote, horizontal asymptote, and optical asymptote, and they ask you to write the rational function. So that will be the next lesson. So stay tuned for that. And thanks for watching, everyone. Bye for now.